Okay, today we're going to talk about some chemical and physical properties. So you guys are going to have to explain and identify physical properties and chemical properties. And we might get to some chemical and physical change here at the end. So what's a chemical property? It's pretty much something that a substance will do that involves chemistry or chemical reactions. And it will always involve forming new substances. So reactivity, flammability, stability, pH, toxicity, all of these kind of properties will cause the chemical substance to change or a chemical substance to change. Rusting, for instance, if metal rusts, it means that it's now a different substance. Instead of iron, it's iron oxide. It's a different substance. If something lights on fire, then it's going to change from the old substance to ashes and gases and that kind of thing. You can't relight ashes on fire. They're not flammable. They're a different substance now. All right, so the whole question is why? Why is the stuff in that beaker very reactive? Why did it blow up? Why isn't that guy wearing goggles? Well, the last question I'm not sure the answer of, but chemical properties are very complicated. It's not something that we can kind of just easily say why it has that property. Why is something flammable? Why is something reactive? It's going to be a little more complicated. Physical properties are qualities that can be measured without changing the substance. So you can't test if something's flammable unless you actually light it on fire. But you can test the color without doing anything to it. You just sit on the counter and look at it. That's not going to change it. So here's some examples. Color, odor, hardness, texture, luster, which is another word for shininess, mass, volume, density, solubility. All of these are examples of physical properties. Again, we can test all these things without doing anything to the substance that will change it. Some explanations. The color is something that's very complicated. But whether something's shiny or its crystal shape or magnetism has to do with what the electrons are doing inside the atom. Whether it conducts electricity has to do with electronegativity. So metals don't like their electrons very much. Therefore, they let electrons go through them very easily. So they're conductive. Mass and volume, well, obviously the amount of material is going to impact the mass. Whether something's dense usually has to do with its atomic mass. So how heavy the atoms are inside of it. The temperature is having to do with the speed of the particles in something. What state of matter it's in, solid, liquid, gas, has to do with the temperature, but also has to do with the molecular forces. So in other words, how sticky the particles are towards each other. And solubility has to do with the polarity of molecules. So you can dissolve sugar into water because they're both a little polar, but you can't dissolve oil in water because the oil is nonpolar and the water is polar, and like dissolves like. So sugar will dissolve in water, but oil is not like water, so they won't dissolve in each other. Physical properties break down into two major categories, which you have to know. Intensive properties don't depend on the size of the material, so things like temperature, density, melting, and boiling point, whereas extensive properties, the size of the material does matter. So the mass of something depends on how much stuff you have. The volume depends on how much stuff you have. The energy content of something depends on, for instance, you'll have more calories if you eat more stuff. So therefore, that's extensive. Intensive properties can usually be used to identify a substance. Melting and boiling points is a way that we kind of define the properties of when something's a solid, liquid, or gas. Melting point is the temperature at which it changes between solid and liquid. It's also the same as something called the freezing point, or the, let's not go there. Boiling points is the temperature where a substance boils. So let's talk about this. Mercury's melting point is negative 39 degrees C, and its boiling point is 357 degrees C. So that means between these two temperatures, it's a liquid. At a lower temperature than this, it's going to be a solid. And at a higher temperature than this, it's going to be a gas. So at negative 50 degrees C, what state will mercury be in? Well, mercury will be a solid, because negative 50 is lower than 39. That'd be like over here. At 101, mercury is not a gas. Mercury is actually a liquid there. Water would be a gas there, but mercury is a liquid because its boiling point is 357 degrees C. So at any temperature lower than 357, mercury will be a liquid. Ethanol, otherwise known as alcohol, melting point is this and boiling point is this. So why don't you guys try doing this one on your own? What state will it be at -50 and at 80? All right, so -50 to me is between these two numbers. So therefore, mercury will be a liquid at -50. 80 degrees C is just above 78. So it's just above the boiling point. So mercury will be a gas there at that temperature. Sorry, not mercury, ethanol. Ethanol will be a gas. And ethanol will be a liquid at -50 degrees C. All right. Chemical and physical changes. We should talk a little bit about chemical and physical changes and what causes something to be a chemical and physical change. You should know that physical changes are changes that don't change a substance. Cutting, grinding, bending, turning something from solid, liquid, or gas, just heating something up a little bit, and that's all physical changes. You're not actually changing the thing. For instance, when you dissolve sugar into water, it still tastes sugary, doesn't it? And the water is still okay to drink. So therefore, that's just a physical change. You haven't actually changed the substance. And most physical changes are easily reversible. All you got to do to get the sugar out of the water is evaporate the water away, and you still have sugar. Chemical changes, on the other hand, another name for this is chemical reactions, result in completely new substances with completely new properties, new colors, new odors, completely new stuff. So you will have a chemical change anytime you have these changes in color and odor. It'll usually have new physical properties. It won't be easily reversible, and it'll involve like absorbing heat or giving off heat without an outside influence. Let me give you an example of this. Heating up water, just because the temperature of the water goes up, doesn't mean that it's a chemical change, because you have to heat it up from outside the stuff. But there are chemical changes that happen where you'll just leave the stuff sitting there and all of a sudden it'll get warm. There are like heat packs. Anybody ever use those hand warmers in winter? It's like it comes in a little plastic package, and when you take it out of the plastic package, all of a sudden the stuff in there starts getting warm. That's a chemical change because energy is being released, but you didn't actually heat it up. It heated itself up. There are also cold packs like that. There are packs when you go and you twist it up, all of a sudden it starts getting cold, even though you didn't put it in a fridge or a freezer. So again, that would be a chemical change, not a physical change. What's happening at the particle level? Well, remember, physical changes, the substance isn't actually changing. So all that's really happening is the particles are moving further apart. In a chemical change, bonds are breaking. The atoms are rearranging into new compounds. So this would be a good picture. In this picture, we see a water molecule is here, and over here, the water molecule is still there. It's just spaced a little differently. Down in the bottom, though, we see a water molecule undergoing a chemical change. There's a new oxygen atom in there. It's got a new bond that wasn't there before. So that's a chemical change. All right. So here are the key differences. Chemical changes, the substance changes. Physical change, the substance doesn't actually change. Chemical properties can only be measured by changing the substance. Physical properties can be measured without changing the substance. That's really about it.